Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how your brain takes in all the tiny movements of a face and figures out if it is moving forward or backward in time, especially when someone is talking or even just blinking? Well, this new study dives deep into that fascinating question. Today we're going to explore a study that uses a pretty cool trick to peek inside our brains as we look at moving faces. Imagine watching a video of someone's face, but instead of just seeing it, scientists can actually tag different parts of the face with different flickering lights, so fast you can't even see them. Then, by measuring your brain waves, they can see how your brain reacts separately to the eyes and the mouth. It sounds like science fiction, but it's how they're uncovering some amazing secrets about how we process faces. So, what is the big idea here? Our brains are amazing at taking in information from moving faces. Think about it. We see expressions change, people talk, and eyes blink all the time. This study wants to know how we use the local movements of specific face parts, like the eyes and the mouth, to understand the whole moving face. They want to see if we process the eyes and mouth differently, and how things like a person's orientation, upright or upside down, or even if they blink, change how our brain works. We're naturally drawn to faces, aren't we? They tell us so much who someone is, how they're feeling where they're looking, and even what they might be saying even if the sound is off. For a long time, scientists studied faces mostly when they were still pictures. They learned that the way the parts of a face are arranged matters a lot. When a face is upside down, it is much harder to recognize, showing we process them as a whole rather than just a collection of parts. But in real life, faces are rarely still. They're always moving. So, scientists are shifting their focus to how we understand these dynamic moving faces. One of the key things this research explores is the idea of temporal direction. Just like a face has a usual way it looks upright, it also has a usual way its movements unfold over time. When you play a video backward, it's not just reversing the motion, it's creating movements that don't look natural. This is similar to how turning a face upside down disrupts our usual way of seeing it. So, the researchers wanted to see if our brains are just as sensitive to the natural flow of facial movements as they are to the spatial arrangement of facial features. They also noticed that previous studies looking at moving faces often use faces showing strong emotions. This made it hard to tell if people were reacting to the motion itself or to the emotion. To get a clearer picture, they decided to use neutral faces that were just moving naturally, like talking or blinking. This way, they could focus purely on the temporal information, the timing and flow of the movements. The central question becomes, how do the different parts of the face, specifically the eyes and the mouth, contribute to our understanding of these dynamic faces? And how do things like whether the face is upright or if Teresa blink change how we process these parts? They wanted to find a way to measure the brain activity from the eyes and the mouth separately at the same time. Now, how did they actually do this? They had people watch videos of faces. These faces were speaking Turkish, but the sound was turned off so people couldn't hear them. The faces were either upright or upside down, and some videos had blinks while others didn't. The really clever part is how they looked at brain activity. They used something called frequency tagging. Imagine flashing a light in the eye region at one specific speed, let's say 6 times a second, and a different light in the mouth region at another speed, maybe 7.5 times a second. You wouldn't consciously notice these flashes, but your brain does respond to them at those specific speeds. By measuring these brain responses, called steady-state visual evoked potentials, or SSVs, at those exact tagging frequencies, the scientists could see how the brain was reacting to the eyes and the mouth independently. They used videos of faces saying Turkish text, but remember, all the sound was off. This was important because they wanted to focus on the visual cues of speech coming from the mouth, and how that might be affected by language familiarity. They carefully controlled the videos, making them black and white and evening out the brightness. Then they put these special flickering tags on the eye and mouth areas. The eye area was tagged at 6 Hz and the mouth area at 7.5 Hz. These speeds were chosen because they're different enough not to get mixed up and are at a rate that can be picked up by the brain.